Okay, I see more than 60 people who are waiting in the waiting room. I request you all to please start joining the link which I've shared with you. Everyone, please start joining the link I've shared with you. Hi everyone. Everyone, I have shared this link with you all. Bhanu is already with us. Hi Bhanu, I welcome you here.
Yeah, hello.
Yes, hi Bhanu. I'm just trying to stream it and all of that. I would take another 2 minutes and then we can begin.
Sure.
Yes, so I hope all of you are able to join. All of you are able to see me, and all of you are able to join. Can everyone hear me, see me? Is everybody able to join the meeting? I don't see anybody else in the waiting room. You could join also the YouTube link and leave the meeting here so that we can have more people in the meeting. I request you all to join the YouTube link till the time so that we can have more people in the meeting. Yes, we are having more people, but we can't join them because this meeting is full. So I request you all to kindly start joining the YouTube link so that we can have more people in the meeting. Thank you everyone who's leaving, joining the YouTube link. Okay, all of you are able to reach to YouTube. I request you all to start joining the YouTube link so that we can have more people in the meeting, please. YouTube link video hasn't started yet. It's showing waiting. Okay. Let me try to fix it. We're just waiting for it to stream on YouTube so that we can admit more people over here. Okay, so we can start with the session now. Bhanu, are you there? Are we ready? Okay. Yes, are we good? Are we ready?
Hello, hi, how are you doing?
Hi, I'm great, Bhanu. How are you?
I'm great too. I'm good, doing well. Yes.
Lovely. So, before we start, guys, first and foremost, apologies for the technical glitch, and we'll be sharing another link for all those who are not able to join. But till then, let me quickly introduce you to our special guest, Neelkantha Bhanu Prakash over here, also known as the fastest human calculator. So, Bhanu, I mean, you're no less than a superhuman to me, believe me, when I say that. And just to tell our audience, Bhanu has 4 world records, 50 Limca records. He won this title of the fastest human calculator at the age of 19, right, Bhanu?
Yes.
Right, at the age of 19. And he's also a TEDx speaker and all that he accomplished at such young age. So, Bhanu, first and foremost, congratulations for all that you've accomplished, and you have made our nation proud. I
Thanks,
have.
thanks a lot, Nandini. Thanks for the introduction. And yeah, firstly, hello all. Hope you're all doing fine. We're almost nearing the end of the year now. So yeah, good time to discuss about what we have to learn and what was going on. Yeah, Nandini, on to you so that we can set base conversation.
Right, definitely. So, first and foremost, I want to just lay the foundation of this session. This session is particularly organized for grade 10 students. Am I audible to all of you? Yeah, am I audible to everyone? Okay, I think there's a lag from Bhanu's end then. Bhanu's video screen froze. Okay. So, to lay the foundation of this particular session, I'll quickly tell you this session is organized by my study buddy, and it is particularly organized because we are seeing that, because of boards being conducted offline now, and all of us seeing that, you know just give me 1 second. We're sharing another link. Just, Banu, I'm really sorry, we're sharing another link. Just give me 1 second. So I really request all of you to redirect on this YouTube video. This is streaming live, definitely, and so that we can welcome more people. The same thing is streaming live on YouTube. We have already checked, and we have already checked with our team. So you all can join this link for sure. This is working so that we can have more people. Thank you so much, and we're really sorry for this technical issue which has been caused. I request you all to start joining this YouTube link so that we can have more people in this meeting. Yes, now talking quickly about the foundation of the session and why we are having this particular meeting. So, as we saw that boards now were conducted offline, and whole preparation, the whole year, students have studied online. Now, this was a situation where students, as well as their parents, were in a very terrible situation. They didn't know how to deal with the whole thing. Students have given MCQs the whole year and all of that. To deal with the phobia of boards, and more importantly, math as a subject, because a lot of students, fear math as a subject. We thought that, we should have a session with somebody who knows math inside out, has dealt with math phobia like anything, and we thought to have you on board, Bhanu. So I welcome you again on this session with all our students who are 10th grade students, and we'll be talking about how to prepare well for board exams, and I'll also be asking some questions which we've gotten from our viewers.
Yeah. So first, as Nandini has mentioned, the boards are one of the trickiest parts of any student's journey in, let's say, going forward in academia. And unfortunately, this year, a lot of learning has been digital, and the fact that everyone's supposed to now give board exams in offline is a surprise and at the same time a challenge. And I personally believe that this challenge and the phobia of math or anything in general has is not what you see today, but it's been there for a long, long time. So, and probably in this session, I will be charting about how I've sort of prepared for my boards, probably a little bit around that. And then also go about saying that what challenges are to be faced. And more importantly, talking about how do you get to that challenge, because there is a lot of questions right around an exam. The exam is not only about being able to learn, but about being agile, being quick, being apt. So several other things. So yeah, I think I'll probably start off. I am 21, as Nandini has mentioned, and I've written my boards in 2014. It's been a long time, yes, but my experience with boards was that not only is this a way in which you test the knowledge which you have, but it's also about, let's say, the kind of preparation, the holistic nature of how you prepare for it, which is pretty important from what I see, especially talking about something like math, which has been the subject with which I've been working for a decade or a decade and a half now. For those who are just joining in, the people who do not know, I hold a few world records. If you have seen Shakuntala Devi, the movie on Amazon Prime, I broke one of her records. In fact, a few of them. And math has always been something way beyond a subject for me. And if I have to put it this way, it's been a sport, it's been an art, it's been something which is celebrated across. In my boards, I had a lot of, let's say, even when you are good at math and arithmetic, right? So math has a lot of angles to it. The subjects, the kind of chapters you encounter, and look. If I have to think back, I think starts all the way from real numbers and ends at constructions, the entire spectrum, which starts from understanding what numbers are, understanding what irrationals are, going about and quickly building abstract mathematical knowledge where you look at algebra and stuff, and also later move into more number heavy questions like be it mensuration, be it triangles, quadrilaterals, proving. So the entire spectrum of math is a huge, let's say, swing, right from understanding what numbers are all the way to correlating it with diagrams and physical entities. So when I look at it as a subject today, I would probably say that I look at it as a game, right? I mean, when I say that there are levels in it, I mean, if you're a 10th class aspirant today, I think it's important to find the clusters of chapters together, which is what go naturally from one to the other, and what do not, right? So it's about finding those arcs. For instance, I'm playing cricket today. My batting skill has nothing to do with my bowling skill, nor does it have anything to do with my fielding skill. Three of them are independent of each other, but only when I do well in both, all the three, I become a good cricket player, right? So I think it's about identifying what you're good at, which is, are you a batsman, are you a bowler, or what are you? I mean, in math again, not in general sense. So maybe I think Nandini can initiate a conversation on the chapters and how I would categorize them and naturally flow from one to the other. Because I think that was the essence of how I learned my math. And initially, I think this is going to be the first 10, 15 minutes of what we have. And then we'll slowly forward ourselves into, let's say, tips and more, let's say, better ways to visualize what you do in an exam, right? So I think we'll go to the exam centric one and the preparation centric one, two things. When we talk about preparation, let's talk about syllabi and then come here. And I'm going to restrict my conversation to math because the mechanism which you use in deconstructing this is going to be very similar to the mechanism which we will be using to deconstruct something else somewhere else.
Right. So, Bhanu, while you were mentioning all these things, I think we missed Trigo. So, a lot of people, they fear Trigo a lot in a manner that, they're like, the moment we see this question, we are like too much in fear that how to solve this question, even after practicing the same question over and over again. So, I want to ask you one very basic question, which was in my head the first time I got to know about you, was that the moment I hear somebody who loves math and is doing math day in day out, there's a certain aversion. I feel that, oh my god, this person loves math. So not a lot of people are able to relate to that bit. So how did you get to love math, and how did that journey start? I want to first understand that, because I want my 10th graders to take up a similar journey or starting to love math when they're preparing for board exams and get rid of the phobia for math.
So I think if I have to put it this way, so again, right, if I have to quickly run through my journey, I was a regular school going kid. I was doing math and everything else as everyone else was doing. I actually met with an accident when I was 5, which got me bedridden for an entire year, where I was not really going to school. At this point of time, I was told that any mental exercise is a good thing to do. So that's when I picked up chess and puzzles. But something which really intrigued me back then was the nature of numbers and how fun they can be, how they hide a lot of mysteries and a lot of treasures which are very worth exploring because they just develop the way you think. So when I was in second grade and a little after that, I realized that math was the one good brain exercise. And if I have to put it this way, think about you running. It's New Year's, right? I mean, a lot of people here would say hitting the gym, being in the gym, working out, being fit, playing sports. So, I mean, if you look at it, we do give a lot of thought around how we maintain our physique, how we go about being fit, how do we go about being better off there. But at the same time, we don't really give a lot of thought about the last time when you gave your brain an exercise,
Right.
right? And this is going to be scarce as you move forward in your life. Until 10th grade, you're at least doing math. You're doing something which is around the worlds of deciphering something or stuff. But a little later, when you move into, let's say, a little different world, which is centric towards your degree, centric towards whatever you do, the nature of putting your brain at work keeps reducing. And that is something which I really found was where my interest was in. And from there, I started going to regional championships, the nationals. And before I knew that this was something which I was building for myself, I was the national champion in speed arithmetic by the time I was in 2011. And obviously, from that, it naturally flew, right? I mean, 2013, I was the international champion. And someone said to me, and I think chance encounter, right? I mean, for the people who know probability, I think it's about being at the right place at the right time, because my extended uncles and aunts were like, okay, you do speed math, so what, right? I mean, you calculator, sure. I mean, I can do it. And my only question to people here today who would probably say, Bhanu, calculations karta hai, to kya hai? What is the big scene? Why is math so important? What I would say is that why do people sing songs? Do we not have them on Spotify on our phone? Why do people walk? Do we not have cars? That's not the logic. The logic here is the reaching of destination is not as important as the journey. And I think that is the case for every mathematical problem. And yeah, I might romanticize this a little bit, but for me, every proof, every theorem, every expertise, every nature of every question solved, be it trigonometry, be it anything else, starts with understanding why would someone even look at this as a problem, right? Why was this an issue? Two, how did they approach towards solving it, and were they intelligent enough, right? I think when you answer these three questions, you'll understand the purpose of every math which is ever done in front of you today.
And I
The
think few people ask these whys, which you just talked about. We barely ask these whys. So
And the
I
moment you ask these whys is when these naturally flow, right? Because the nature, and in fact, I mean, let me not deviate a lot into celebration of math only here, because sure, I do have my world records on whatever there are, but the significance and the practical significance of it is when, let's say, when we are in a competitive exam, when we are in a school exam, when we are in a board exam, whatever, there's a challenge in front of you, there's a question, and I would not call an essay writing a challenge, right? And the reason why I would not do that is because if I have to put it this way, funnily enough, math is one of the easiest things to answer. And I'm telling you why. Because the nature of arguments is always linear, right? So when I say linear, you understand it's in a line. So when I say, can you find the area of this triangle, right? I mean, let me just say, as simple as that that might sound. Let me just probably share my screen here. Area of this triangle, which is 3, 4, and I mean that's horribly wrong metrics, but 3, 4, and 5, right? When I say the area of this triangle, everyone can take a different approach to solve this. One can say this is half into base into height, which is going to be 6, right? Pretty easy. Or someone like a practical mathematician would say it's root 6 into 3 into 2 into 1, which is going to be 6. And this, as people know, probably see, is called the Heron's formula. You would have probably gone across this in multiple places. Now, both of them work. Half into base into height works, this works, right? But a mathematician has the luxury to choose what he would want to do as long as he can logically, what do we say, argue it to himself that both of them are possible, right? Now, if I have to look at it this way, when someone asks you any social science question, which is what is the beginning of the civilization, then there is 100 argumentative points which I can bring towards to start and a lot more to cover. But in math, it's linear. I start here, I end here. I can choose the path, but I'm going from the beginning to ending because there is a beginning to ending to every question. And I think that is something which is not a part of a lot of things in life. For instance, and that's what makes it beautiful, the absolute nature of whether it's right or wrong. And if you have to look at it in a board exam, I think it's about figuring the starting, the ending, and the possible paths to reach there. And this is the case for every trigonometry problem. I mean, I might be trivializing this a little too much, but at the end of the day, I think what we definitely know of in every trigonometry problem ever is that that's a question, there's an answer. Sometimes the question itself is the answer. This is called a proof, right? This is called a proof. And there are a certain set of logical steps which will get you here, right? The certain set of logical steps can be tools which you get, right? The tools which you have, which is, let's say, something which you know of, an identity, right? This is an identity. Sometimes it is something as trivial as visualizing it in a triangle, opposite by hypotenuse. Or sometimes even to an extent where you just break the tan into sine and cos. Now, these are identities. Now, what I'm saying is that a mathematician is just someone who is like a builder. You have a building to build, you have a plan, but you have your bricks, you have your cement. But you need to know that you need to put the right brick in the right place, right? And it's just, and the only way you know it is by doing more and more of it so that after a certain point it naturally flows. For instance, I'm talking to you right now. My hand positions and let's say the gestures are automatic, but these are not thought through. But these are conveying what I'm trying to say to a certain capacity. So it's intuition. So mathematics and intuition work very closely, and the more you get it, if I have to put it this way, for someone who makes a rumali roti back at home, it is not very hard to keep doing the rumali roti again and again. By the first time they actually did it, it was really hard. So I think that's what the key towards this is. What are my tools? What is the stuff I have? And how do I get to where I get? And that is the nature of every calculation problem ever. So I mean, if a little later we can probably see me doing a few calculations, that's how I arrive at where I arrive. And the nature of, let's say, the journey towards an answer, the moment you visualize it, and every time you look at a question, you say that this has been my journey, this has been my hurdle, that's how I moved past it. If you can critically appreciate to every problem you have, you are there. And I think there's nothing easier than math as a subject once you get there. Because I mean, I personally realized that once you build this with 3 questions in your exercise, you're good. You don't really have to do everything to get to the right answer.
Wow. So, Bhanu, I really liked how you mentioned about Rumali Roti and how we discussed this about trigonometry, that how, you said it's a journey and both the things they meet and there's a vehicle which we take. So very ironically, one of my students, they told me that, if you start from the beginning of the question, you get stuck in the middle, you start opening the equations from the bottom and you'll still get there. And once you get there, he was telling me that as if, the child was telling me as a discovery. And this was not something teachers really appreciate and they tell students to do.
And I mean, adding on to it, absolutely, because a lot of proofs which I did back in school started from the bottom and then went all the way up. See, it's one thing which I would say is that regardless of which school you are in today, I mean, regardless of where you are in, it's one thing to be creative and the other thing is to be intelligently creative. being intelligently creative means that your creativity is sort of presented in such a way that it looks academic also, right? I mean, this is, I think, the good juncture which kids don't, I mean, we don't really appreciate people doing it because we don't really have a lot of thinkers out there. And unfortunately, that's because not a lot of teachers even promote certain ideology of that sense. But I mean, a few examples, and this is something which you'll see more often in mathematics after 10th than not, right? The concept of intuitive way to arrive at something is not appreciated. For instance, when you were, let's say, a student, you're probably told that, okay, this is the procedure, this is how you go about it. Now, the two ways is that I'll go about mine. The other way is to use your creativity to critically appreciate why the way they made the way they made, why is that something which is universally accepted. Because I think that's when you understand a lot of things. For instance, I mean, again, I'll not bring it up, but for the people who are just starting off in their 10th, finishing their boards, a little later you'll realize that there's something called integration which comes in 12th grade. I mean, I'm not going to go into the details of it, but that is one place where you'll appreciate intuition than anything else in the world, because it should occur to you. That's it. The way it should occur to you is something which is not demanded of you before. But if you are a certain kind of person, for instance, for me, I absolutely found constructions to be the most bizarre chapter in the entire 10th grade. I would leave it away and I would say that मुझे 5 mark चाहिए नहीं, मुझे नहीं करना, because it's I felt that it was very repetitive and let's say things. But now that I look back at it, it has its angle, it has its own way of let's say looking at the world in general. And in fact, one of the most um, powerful theorems, which I personally think we don't stress enough in 10th grade, is the beginning, which is, I mean, the first chapter right there, root 2 is irrational. There's a proof, if you would have probably seen. Root 2 is irrational. Root 2 is of the form P by Q. You go about doing a lot of stuff, and then you say, no, it can't be. Right? Now, that is of cards. You should have. Yeah, cool. Nandini, can you sort of restrict people on multiple screen sharing? Yeah, and probably immediately share it, make me the co-host, because that'll be easier. Multiple sharing, okay, and then give me the co-host. That'll be easier.
Yes, Bhanu. So I'm just making you the co-host. I have done what you've just said. Cool.
Also, apologies, guys, for the people here. That's always a part of, let's say, being in the digital era. So it's fine. I mean, it happens all the while. Looking at this enough, yeah, cool. Thank you, Nandini. So we personally believe that the way maths has to be visualized is something which is very important, and asking why is it every given point of time is a great thing to do. But at the same time, the entire nature of, let's say, remembering formulae and sort of that being your only resort is something which I find a little, what do we say, hatke. It's an adjustment which you're doing to yourself, but not something very, very, what do we say, that will not make you love math. So if I have to put it this way, it's about listening to an audiobook using something else. The other is to appreciate poetry, right? The two different things. And the only way you can do that is when you visualize what you're doing. For instance, when someone says a plus b whole square is a square plus b square plus 2ab, or let's say a plus b whole cube for the people who are in 10th is a cube plus b cube plus 3a square b plus 3ab square. We remember this, we try to remember this so often that we sometimes fail to sort of even understand and appreciate what this means. And something which I think I personally feel is a really good application of what I see. Again, I'm not going to do the regular draw square, show the squares and how they go about it and stuff. But this is something which when I was in my 10th grade, started doing squares like. And even when in my further initiatives today and wherever I go, which is through exploring infinities or whatever other stuff, I genuinely tell that this is one of the biggest applications of algebra, which you will witness here right now, right? I'm gonna show you guys this. So if I have, let's say, 106 square, Vedic math will tell you do something, get to the answer. Sure, cool, great. But let's look at this algebraically, all right? Only algebra. So let's only concentrate on the algebra of it. How do I calculate this? A lot of people say 100 plus 6 whole square, use the formula, cool, great, okay, sure. This is when I realized that maybe, and this is something which I thought was a discovery back then, but this is when I was in eighth grade, all right? I'm not very, yeah. So if I take this to be 100, right, which is 6 lesser, ideally I would, this is easier for me to multiply with anything, right? It's easier. And multiplying anything by 100 is easier. And you break this and extend 6 here. So the square which I had, I converted that into a rectangle. Okay. So I converted that into a rectangle. So this is going to be 112, right? 106 plus 6. So what I have is 112 into 100, which is 11200. And if you see this part, this goes and fits right here until here, except this, which is a 6 square. So if I add 6 square to it, I get 11236, which is this answer right here. Right? This might not seem very natural to you, but essentially what we just did here is this. 106 square is nothing but 100 into, if I have to put it this way, 106 minus 6 into 106 plus 6 square. Take the 6 square to the other side, you exactly know what we are doing. It's 106 square minus 6 square is this, which is a square minus b square is a plus b into a minus b, right? The formula, great, but it has its geometric meaning. The moment you want it to have a geometric meaning, it has a geometric meaning. So I think identifying these things were a part of me starting to love math, and probably even looking at stuff like something which I realized when I was back in 8th grade. I was like, okay, 1 is 1 square, 1 plus 3 is 2 square, 1 plus 3 plus 5 is 3 square. Oh my god, if you add odd numbers, you always get to the square of it. And I really thought this was something which I personally sort of somehow, n odd numbers, if you add, you get n square. I thought this was something which was great, a very good observation. But if I look at this, this is something which is very intuitional. 1, okay? And if I say 1, 2, 3, right? That's 2 square. 1, 2, 3, 4, 5, that is 3 square. And if I go on, 1, 2, 3, 4, 5, 6, 7, that's 4 square. 4 into 4 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, 3, 5, 7, 9. Add them together, it's obviously 5 square. Looks, you can actually feel and see what's happening there. It's no magic. It's absolute arrangement. And I think one of the most beautiful ways of visualizing a basic identity, which is, and mind you, this is something which you can derive, and I'm not gonna push it a lot open here, but you can see it that if you do sum up to n terms of this, let's say arithmetic progression, this is going to be 1 plus n by 2 into 1 plus n minus 1 into d, which is going to be 2 into, and then once you do all of this, which is going to, it's going to look something similar to what I'm going to draw, or what I'm going to show you right now, right? This happens, and it shows you n square. So now what I've shown you is arrangement, geometry, algebra, and arithmetic progressions. All of them in one example, which shows you how interrelated and correlated math is. And the moment you see it is when you understand this is something which is exceptional. And I think that's what I found. And today, the reason why I had Exploring Infinity is which talks about math in specific. Obviously, it's not an effort towards school syllabus or school syllabus interest generation, but about how you fundamentally break down, be it machine learning, anything you talk about in the world data, right? I'm throwing tomatoes at you. I'm throwing tomatoes in a direction. How do you run? Right? I'm playing PUBG. I'm shooting you. Where do you run? You're a bot. How do you know where to run? So these are questions which math has a secret answer for, and something which we believe is extremely important for kids to know, regardless of whether you take math or not in what you do later on in life, be it biology, be it doctors or whatever you want to become. The concept of stochastic processes and probability will never leave you. It's probably not a dice game, but it's going to be about your vaccine success. And and yeah, I mean, all of this, but it boils down to my love towards numbers, which is what is 87 times 87? I know for a fact that it's 7569. But can I use this to train my brain? Sure. 87, 174. If I have to say the table out loud for 87, it's going to be 87, 174, 261, 348, 435, 532, 609, 696, 696, 783, 870, 957, 1044, 1131. This is one of the records which I hold for. But it shows you how quickly you can think, and how quickly can you think can be measured only through your math expertise. So it's like a double-edged sword. Know yourself, know math to know yourself. So that's, I think, where I would probably give it a couple of break so that you can jump in. Yeah.
Right, lovely. I mean, I also saw one of your interviews where you mentioned that, this whole journey helped you understand how you can challenge human cognition in a manner that to understand how can you harness your brain and to really expand the limitations of a human brain. And I mean, honestly, you've proved yourself not just by expanding the horizons of human cognition and our brain, but also by practically putting it into action. Like one of our attendees have also asked this, that I never understand the usage of these chapters in my future. So I think you very well answered that question, that how these chapters are very well present in the physical world.
And probably, I think one of the biggest questions I probably leave out for the open right now is that the people who are here or on the YouTube chat, I'm on both. Any chapter which you think is actually irrelevant, let us see if we can bridge that. So that, see, first thing is to build the intent to say that, okay, it is there for a reason. Two is to know why it is there for a reason. It's just not assuming and saying that, okay, it's there for a reason, I need to study. But it's also what, let's say, you know that very reason. So any chapter which you personally think has no absolute application towards, and I'll tell you how that probably helped me in my journey. So that I think that can be a good exercise for a couple of minutes. Anyone here in the comment section, even right now, if you push one, or we can push forward. I see constructions and trigonometry. Okay, those are things which I'll take out anyway.
I have a couple of more chapters for you, Bhanu. I wanted to, really help our viewers by this. So we at My Study Buddy, what we are also doing is we are covering all these chapters in our crash courses. And I wanted to know this for ourselves as well as for our students who are there in the crash course as well. How can they quicken their bit? How can they make sure that, all these chapters they're learning, they're able to do the calculations faster? So a lot of students, my students, they face a problem here. They don't know how to do the calculation for volume surface area, the questions which have a lot of heavy calculations. They have to cut it with the value of pi, multiply, and particularly for statistics. How do they really put all these calculations and do them faster so that they're able to save some time and put it in revision? So can you please help in that?
So let me bring back an example from sports, right? If you want to perform good in your playing football or soccer, you need to have your warm-ups, right? It's as simple as that. The more you keep playing football, doesn't mean that you get fitter. Your fitness has an alternate route. One is to know and be better conceptually, and the other is to be quicker. And the quickness is an entirely different parameter altogether. How I suggest people do it is to actually recognize that it is an alternate path. Right? One thing which we have to understand is that if you want to get quicker at calculations, it cannot be a part of you doing the same questions again and again and see that you can become quicker. Practice is great. Directed practice is better. Something which I think I speak everywhere. Everyone says that math is all about practice. I don't think so. I think math is about deconstructing a thing into smaller segments. And once you do that and you know your basics, practice does not really affect anyone as much. I have scored 120 on 120 in JEE, right? And I think that math is the least subject I've practiced. And it's not that I'm naturally talented at this or anything of that sort. It's about knowing how everything functions and being able to do quick calculations. People really look at this as something which might not be the most important thing there is, but it is. And I'll tell you why. Because agility in calculation can translate into agility in thinking. Agility in thinking can be translated. It's like this, right? Ki you're able to walk quickly. Say, if you're able to run quickly, that doesn't mean you can't swim quickly, right? You're going to get better at swimming also. But running is what we are using as a measurement tool. And arithmetic is the best measuring tool. So what I would probably say is that you start off by simulating the kind of calculations you might have in the school in a thing. And in fact, this is something which I tell everywhere, which is about the fact that doing multiplications, I think, is something which a lot of people think that there is a lot of problem with. Don't understand. We don't do additions properly. There's a lot of thing around this. So Nandini, if you can quickly share me the host credentials, let me share and showcase something which probably we will understand. And I'll answer a couple of questions which are coming from the other side also, um, which is, let's say, Akshat's questions on pi and stuff. I'm going to get to that. But if you can, yeah, I think you have, right? So when you take a multiplication, right? Let's say 873 multiplied by 8. Now the problem with this is that we say, okay, I'm going to do this now. Okay, 4 times 3, 3. I'm going to put 2, 56, 8. I'm going to say 8, 5, 64, 69, whatever, and then come to the answer. Now, this is great, but I fundamentally think that the reason why people are slower in calculations is because of the direction. It's when I say math is like playing cricket, it actually is like playing cricket. You cannot play with an ulta bat, right? You should not, ideally. So I personally feel that going ahead with this, using the properties which we know, is the way. And something which I would not say is genuinely Vedic math or anything of that sort, but something which I promote everywhere I go is starting to look from the left to the right. Be it addition, be it subtraction, be it multiplication, because from division you do that anyway, right? From division and square roots you do that anyway. It's not that I have to mention it out loud. Now, the question here is, what is 800 into 8? We know that 800 into 8 is 6,400. Not very hard for us to understand. 70 into 8 would be 560. I'm putting it here. 3 into 8 would be 24. The moment I add this, is going to be 5984, right? That's my answer. But this seems bizarre because what are these zeros doing here anyway? This is something which I thought to myself when I was in school. I was like, why are these even necessary, right? They're not. Ideally, they are not. They don't mean anything to us, right? They're just telling us where these positions lie. So when I looked at 873 into 8, I'm going to use the same question. When I was in school, I just thought to myself that, okay, 64, 56, 24, okay, 4 here, 8 here, 9 here, 6 here. That's the answer. Right? It's 6984. I don't really have to do anything else here. Now, and I was like, can I even dumb it down a lot better? I mean, because the mistake here would be, I don't know, I might add 6 to 6. I don't know. I can be skewed in my thought, right? So this is when I started it's not discovered. This is a way in which I do my multiplication today, right? I add these, I get the answer, right? It's as simple as this. I take 64, 56, 24. I get 6984. That's my answer. I get to this. And I add adjacent numbers to everything. So if this was 4 and there was a 3 here, no problem. This would be 24, 32. And this would be 4 plus 3, which is going to be 7. So this is not going to be a 4 here. This is going to be a 7. 2. And this is not going to be a, what do we say, 6 here. This is going to be 0 and a 3. That's my answer. Now, on an alternate route, I personally think that this changes the way you think because we are rooting for something called optimization here. I'm not sure if a lot of people are familiar with this word. Optimization means that आपका घर इधर है, किसी और का घर इधर है, तो हमको ऐसे ऐसे घूम के नहीं जाना है. That's what optimization means. Optimization means that I want to go this way. Displacement is the first measure for optimization we would have come across until now in physics. But optimizing the way you think is very important. And this is the case everywhere. So, right, for instance, if I am doing a trigonometric question, right? If I say that I'm going to solve a trigonometric question, which is something, 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 should I substitute my sign first? For instance, let me show you something here, right? If I say something like, I don't know, I'm just looking this up, right now. Let's see if this is meaningful per se, right? I'm here. Now, let's say I have to evaluate. Let's actually not take an example. The reason is when I take an example, I'm just talking one angle to it. Let me make it abstract, like a mathematician does. So what I'm going to say is that there are several places and several times in whatever simplifications you do where you double do things, which is that I'm going to take substitutions for sine, then I'm going to do something else, then I'm going to do the same tans again, but I am essentially not knowing what to do, right? So ye baat ye hoti hai that for me, sometimes a lot of questions, And this is why people waste a lot of time in their board exams, which is I'm going from here to here. I take a route. I believe that this is correct. Then I come back. Then I go back in this way. This might look very weird to you, but let me tell you how. A very quick example with polynomials, which is if I have something like x plus a whole square plus 3ax minus x minus y whole square is equal to, I mean, let's not take a and x, let's not go to three variables now, just give me a moment here. 3ax minus x minus a whole square is equal to 0, and I say simplify this, okay? Nothing much. I just say simplify. Or this, you come across this polynomial or this whatever in some point of the time or the other. Now, I know a lot of people who would do this, right? I know a lot of people who would say, okay, minus x is equal to 0. And then they'll eventually go x square plus 2ax plus 3 will become 5ax plus a square minus x square minus a square plus 2ax. So they're going to cancel these. They're going to cancel these. They're going to finally say it's 7ax. Now, this is good. I know a lot of people would say a plus b whole square minus a minus b whole square, whatever. I'm going to do this theorem here because I see that theorem there. Okay, I will do that. So if I take it that way, this is probably going to be x plus x plus x plus a, which is going to be this is going to be 2a, which is if I subtracted 2a, and this is going to be 2b, and then if I subtract them, I'm going to get 2x, and then I'm going to finally get to this, and I'm going to still get 7ax. Now both of these are great roots to take, sure. But sometimes what happens is, this is again, I mean, if I have to look at it this way, this question is here. This method is finally getting me to the answer. I'm having to use a theorem here. I don't have to use a theorem here, right? So it's my conscious choice to take what route I want to go for. So ideally, if I am confident about my theorems, I would take the second route. If I am not, I'll probably take the other route. But if I have to put it out there, this is a choice you need to take multiple times in the same question, in questions, in exercises like quadratic equations and stuff, right? In that, every choice you make actually reflects in what you do later. So expanding a bracket, so think of it, these are norms, right? आगे बढ़ोगे तो पीछे नहीं बढ़ना है, तो bracket expand किया है, फिर से bracket नहीं बनाना है ना? These are things which you need to know, and you will understand yourself as long as you tell yourself that I'm never going to repeat something which I do. And I'm going to tell you, after looking at over millions of children who are in 10th grade and the way they approach us, almost 60 to 70% of the time, your answer is not the most optimized path. So spending a couple of minutes on seeing how this eventually might fare is important, right? अगर हम देख रहे हैं कि ये करेंगे तो मुझे x plus a whole cube का I have to go for it at the end of the day, I would not want to do it. If I don't know the formula, I would never do it. I would say x plus a whole square, expand, then multiply it again. So this is something which I did. I never really memorized x plus y whole cube's formula. I never did it. I never thought that it was required by myself because I was quick enough to say x plus y whole cube is nothing but x plus y whole square into x plus y, exponents. And this is going to be x square plus 2xy plus y square into x plus y. And then I say, okay, this is going to be x cube. This is going to be 2x square y. And this is going to be xy square. And if I do the same thing again, I'm going to get a x square y and then 2xy square plus y cube. Are you quick enough to do this? If you're not, you remember the formula. That's it. So I think it's about these choices you take. Ki aapko, math is never something which you need to memorize. And I really would never suggest any one of you to do so. But to know your pace is important. And to actually bring it back to where we started, how do we get quicker at calculations? I think it's about figuring out and actually putting a bunch of questions in front of you. In fact, what I'm going to do right now is I'm probably going to shoot out a small, maybe a small exercise to you right here, which you can probably do it at your own leisure. Which is, if you open the said link which I've posted below, that can be your workout. It can be your 2-minute workout every day to get you quicker at calculations. You can go for it, give it a try. It just helps you do things in a very good way. It's a play. If you see, it's not activity, it's not an assignment, it's a game you play. And that, when it goes with the subject knowledge, it gets extremely, I mean, having the subject knowledge, having the speed is what a perfect attempt at an exam is. So yeah, expinfy.com/play. That's where you'll find a lot of games with basic arithmetic, which you can do and go for. Yeah.
Right. So, Banu, I want to ask you one very, very important question, which a lot of students, would have in their heads as well. That while I'm sitting to attempt the maths paper, now I'm in this situation where I have a paper in front of me. I know, say for instance, I know 80% of the paper and 20% of the paper I do not know. How do I attempt that paper, and how do I manage to attempt the 20% paper, which I'm not extremely very confident about?
Okay. Since you 10th graders, I'm not going to go into base theorem to tell you why it is the most strategical route to take about this. But I'm going to tell you something, which is it's almost always not important to attempt an entire paper. It's almost never as important. What is the problem? And let me just tell it to you this way. At the end of the day, okay, this is going to be the person who's going to be marking you, right? He's going to be looking at your paper. She's going to be looking at your paper. And then they have question one, question two. Let's say your question paper only has 5 questions. Okay, this is me dumping it down to the base minimum. Okay, you don't know this. Okay, you don't know this. Yeah, let's just say I'm not sure what the marking scheme right now is. Let's assume that this is for 90 or 100 for my purpose. So this is 20, 20, 20, 20, and 20, right? The moment you know that you don't know this, and the moment you know that you know these, this is something which I always used to do the moment I went into an exam. Okay, on the scale of 1 to 5, I used to say how confident I am with this question. Okay, let's say this, right? This is something which I used to do in the first 5 minutes, and this is not just here, but this is something which I did right with every single one of my exams ever. I'm going to say, okay, 4. Okay. Let's say this is another 5. Okay. Let's say this is 3. Okay. So, and this is 1, say, right? My job of the entire exam is to maximize the number of stars I collect. Okay. Now, this is the logic. Okay. Because each star obviously correlates to 4 marks. If I have to put it that way, you understand 20 by 5 is 4. All right. Now, if I have to look at it this way, think of it. You have 3 hours, right? And how many stars do you have? 9, 14, 17, 18. Which means that you can give each star 10 minutes. I mean, this again, I don't know if this is something which is very practical for you to do, but we have 180 minutes and we have 180 segments, 18 segments. So I don't actually mind giving 50 minutes to it. Do you understand? I don't mind doing this. Because even if I give 50 minutes, I'm getting and correlating, getting the right thing. So time management and time splitting, this is how I usually go about it. And I don't mind giving 40 minutes to this because I know that this is the scene. And I can always juggle it, right? When I go into it, I know that, okay, aa gaya hai, nahi aaya hai. Question mark bhi ho sakta hai, right? There can be several things you might not know. Trigonometric question देखोगे तुमको लगेगा कि हो सकता है, हो नहीं सकता, मुझे नहीं पता. Right? तो वो बात है, वो उधर you just put a half, right? So you know कि अगर try करोगे 20 मिनट में आएगा तो आएगा, नहीं आएगा तो नहीं आएगा. So my stuff would be that 1.5 hours I attempt what I know, right? I attempt what I know. I would go for it. I'd go full into it. So ideally I would get 30, 40 marks here. And whenever I get bored, I take an additional towards the end and keep writing on this, right? That's usually how I used to go about it. But again, I always had a bizarre method to go about this, right? But my thing would be take a paper, write what all you know about the question you don't know, keep it there. It's always good to have something on your thing. And that's when I would explore this. This requires time. So you know that you know it, but you don't know a bit of it. So you need exploration. So this needs more time. So I would say go for the questions which you're short, you know what to do. And the second section would be that, okay, I don't know, I should give it time. But I think once you have a certain amount of time attributed to every question, right? Usually what happens is that when you do the questions, you know, it takes 1.5 hours and then you're just 2 questions into your paper. And that's a problem. So you need to sort of look into it. And I'm not sure but how the board practice now is, but there used to be smaller questions, longer questions. Some people used to say the best way is to go from the reverse, piche se aage. Some people say the best thing is to go from aage to the last. I personally felt that doing it from the beginning to the end is nice because two marks wale question aate hain ya nahi aate hain, it's fine, it's good, it's cool. I mean, I don't mind it. So I think everyone has their own comfort zone. There's no one standard way which works for everyone. But I think one standard way which works for everyone is to know what you do first, to get that morale boost, to go for questions you don't know. And be okay with leaving the questions you don't, because sometimes that's where we end up putting efforts for literally no outcome. So if you're a gambler, you would know that in a lucky chance, you would give the least amount of your money. So yeah.
Right, and I think Bhanu, you imparted a very important piece of information to all the students who are appearing for board exams this year. That a lot of times we become very very anxious and we don't know what to focus on, what not to focus on, and we end up focusing on being anxious and focusing on the questions we do not know and wasting our time. So, lovely piece of advice. I'm sure it is going to help a lot of students. Now, talking about, you can hear me, right? So now talking about a couple of other chapters like quadratic equations, a lot of students face a problem in that. I would like to know a quick hack on that, and I want to share another piece of information from my end to the students. So if you can give a quick hack on quadratic equations, and I would love to ask you some impromptu calculation questions. And
Yeah, Nandini, if you can pass.
yes. Actually, I was not able to unmute myself, so I had to take the access. I'll just give it to you. Just give me 1 second.
Okay, I think the first fundamental thing which we need to, I think everyone has to understand, is that quadratic equation is something which is, I mean, if I have to put it this way, I have to dump it down to the bare minimum. If this is the coordinate axis, right? This is x, this is y, or whatever, x, y, whatever they are. In functions or whatever, we have learned, in not functions, but any linear equations, we have learned that lines are equations, linear equations in two variables. We have looked into this. I mean, you probably would have done it before quadratics or after quadratics, depends on which school you're in, right? So a quadratic is something which is slightly deviant from the linear way. So the easiest example which I have to say is that the quadratic which you see in the world around you is when you throw a ball, right? When you throw a ball, it falls all the way, comes here, falls here, right? So the shape this takes, you see, this shape. This is a quadratic equation. I think that's where people actually realize that there is a purpose to this, right? That it's not a circle, it's not a semicircle, it's a quadratic equation. Can someone tell me what the nature of a body which is thrown here would be? And let's actually come to physics from physics to math here, because I think intent is more important than, let's say, this. What is happening to the ball which is thrown here? Can anyone suggest? I think Nandini, if you can also say what
Projection.
yeah, the projections. So there is a certain speed which it has here, and there is gravity here, right? The two things, right? If I'm correct, is that what it is? I'm throwing it to the speed. It has gravity on it. Right. So if you see, a quadratic equation is nothing but a deeper push here with a smaller push here. Does that make sense? I mean, it might not entirely, but this is consistent. Gravity hai, Earth is always there. You gave the speed only once. Do you understand how the Earth is overwhelming the speed there? Now that is what a quadratic equation is, right? Now let's come to this. The simplest quadratic equation we are taught in school is x square. Right? X square is a quadratic equation. So yeah, some people say that a quadratic equation is of the form ax square plus bx plus c. Put b is equal to 0, c is equal to 0, a is equal to 1. You have x square with you. Okay? You have x square. Some people say x square. Cool. Now, what you have to know is that this has more tendency to go up than this. It flies. And I mean, this is just the nature of thinking of what it is. So, yeah, cool. I'll help with that. Now, a lot of people here in school, what we are taught of is usually roots of a quadratic equation, sums of the roots of the quadratic equation, alpha, beta, something keeps happening, right, all the time. I mean, we have heard all of these. I mean, I'm not sure if this is a part of the syllabus now or whatever, where we talk about minus b by a, c by a and stuff, right?
Productive fruits is, yeah.
It is.
It is.
Now, you just have to understand that x something, right? Let's say this. A root of a quadratic equation is something which is 0 when you substitute it in it. So let's say if there is ax square plus bx plus c, the moment you put something into x, it becomes 0. Which means that if you look at the diagram of it, it should touch the x-axis. So somewhere here, whatever. Now this is 1, this is 2. There are two roots to the quadratic equation, whatever. Now, I'm going to create a quadratic equation where we know the roots, which is x minus alpha, x minus beta is equal to 0. Now, what I have here is that the moment I put alpha into this, it becomes 0. 0 into 0 is 0. The moment I put beta into this, beta minus beta is 0, beta minus alpha is 0, 0. So alpha and beta are the roots. Do I really have to tell you that alpha and beta are the roots? Not really, because you can see it right there, right? That's the reason why someone actually came up with this. It said that if I want to know the roots of a quadratic equation, it should look like this. Okay, now I know what these are. The moment I expand this, I get something like this. You can do the drill. I'm not going to do this. You're going to get something like this, right? Now, this looked bizarre, right? If someone told you that this is the standard form of a quadratic equation, you would probably say, hey, hatna, nahi karna. So it does not nice. Why is there a minus? What is this? This is not something which I want to do. So someone also said, so imagine this is dude one, right? This is dude one who said this. There's another guy or another woman who said that, okay, let's look at quadratic equations like this. Now dono ka jhagda ho gaya. The only way you sort it is by comparing both of them. So they did stuff. So they had to remove the a. They divided it. They put it here. And they compared. So they realized minus alpha plus beta is b by a. C by a is nothing but alpha beta. That's how you've come to your derivation. So it's about two people's observation to a common point. तो आप देखो किया क्या हुआ. एक ने इसको देख के बोला है कि ये x minus alpha x minus beta है. एक ने इसको देख के बोला है कि ये ax square plus bx plus c है. दोनों को कंपेयर करोगे तो अल्फा प्लस बीटा का फॉर्मूला आ जाएगा. Now that is how I used to look at this, and I personally think that these two people are very important. एक जो हमारा लाइफ को इजी बनाने के लिए ट्राई कर रहा था, एक जो मैथमेटिशियंस को विजुलाइज करने के लिए ट्राई कर रहा था. both of them up and down towards solving what this is. So all the attempts towards squarings and finishing your squares and stuff are towards understanding ये दोनों को relate कैसे करें. That was the whole logic towards this. So yeah, I think that should be it.
Before we go ahead with some impromptu questions, which we want to ask Bhanu, is there anybody in the participants who want to say give a mathematical equation? It could be multiplication, division, anything to Bhanu, and let's do this quick activity. Bhanu, are you up for it?
Sure, absolutely. Why not? Yeah.
So I'm just going to wait for another 30 seconds. If anybody, in the chat wants to do it, anybody from the attendees. Else I can.
But a lot of people who are actually asking me why do we take pi as 3.14 and stuff. What I want all of you to do right after today's class, I'm not going to explain it now because we don't really have that sort of a time. But I have posted a link here, which is of my Instagram page. It has a post specifically on pi and why it is not 3.14 or why is it 3.14, whatever. It has a small Instagram reel. You can go through that. I think that's better. Yeah, go ahead.
So I think a lot of students also don't know what pi stands for, right?
Yes.
How many of you guys know what pi stands for? I just want to know out of curiosity. Bhanu, have you done this experiment, a social experiment like this? How many people really know about pi?
It's lesser than 80%. It's less than 20%. Sorry, 80% of the people don't. I mean, 80% of the people who know that pi is an irrational number is the most problematic statement in the mathematical school universe, which is they don't tell them what pi is, but they say that it's an irrational number. So people don't even understand irrational numbers because of pi, because 22 by 7 is irrational for them, which is a problem. So
circumference upon diameter.
Yeah, but circumference upon a diameter, depending on how good your measurement scales are, keeps going to an infinite loop, a never-ending cycle. Which will never end. But the reason why we take 3.14 is because we are conveniently ignorant of the fact that it's a never-ending one, nor do we have a choice. So, yeah.
So before we move forward to yes, Bhanu, sorry to cut you, please.
Go ahead. So I think the nitty-gritties of math is not a part of board preparation, sure. But for the people who are genuinely interested towards this, we at Exploring Infinities have deviant courses from school, extremely deviant ones, right? We have stuff like something called the monkey theorem, right? A mad monkey theorem basically says that an irrational monkey is something which does not know what it's typing. The more you keep typing onto the keyboard, it keeps generating random strings, which says that there is a possibility that the monkey can actually spell your name. There is a chance that the monkey can actually write the entire Shakespeare poem in that order, because it is irrational and there is a chance for anything to occur in an irrational world. right? So the monkey theorem. So we actually have a lot of discussion around this, around something called turn on the computer in you. So for the people who are probably interested, you can go through that also a little later. But
Right.
stick to the exams. I would say that inquisitive curiosity sometimes is not really nice for an exam's point of view, unfortunately, and sometimes you have to stick to the book. And I think in the deliberation to stick to the book, you learn a lot too, which is why am I not able to sort of do this like the way I wanted to ideally do this. So yeah.
So, Bhanu, there's one of the question which I've received from a participant. I'm just sharing it with you. It is in the chat window. Value of x, y, and z such that x cube plus y cube plus z cube is equal to k for each k from 1 to 100. Can we answer this question?
Uh, okay, controversial. Reason being that it's pretty. What do we say? It's what the question which we have gotten here is called a Diophantine equation, right? It's called a Diophantine. Diophantine means that okay. The question is, am I allowed to take any numbers or is it integers? Well, that's a big question which I need to ask you because the moment you say I can take anything, then it's easy for me. I can just substitute anything in X and Y, calculate this, I didn't tell you. But I think if the question I think means here that it has to be integers, 1 1 1 0 0 1 1 0 1 1 1, then if you want to get a 4, that's when the trickery begins, which is that you need to take -2, -7. Sometimes the combinations even extend all the way to -3000. So what I see here is a complex Diophantine equation if fractions are not allowed. So that's probably not how I'd want to solve it. But if you think that the question you asked is not as complicated as I think it is, then the answer would be this. I would take x cube, y cube, z cube so that it becomes k. The k becomes from 1, 2, 3 all the way till 100. So what I would ideally take here is if I want 10, I would take this to be cube root of 10 by 3. Now that is the most convenient cube root of 10 by 3. If I have to put it this way, it's going to be cube root of 10 by 3. So cube is 10 by 3, 10 by 3, 10 by 3, add them, it will become 10. So I would say this. Cube root k by 3, cube root k by 3, cube root k by 3. For any k works for any k, wherever it is. But if you meant integers, then I think we need a computer. A human brain cannot do this. So yeah, Diophantine equations are harder to find. In fact, Diophantine equations are used for putting the world's most complicated cryptographic systems. In fact, for me, the way I'm looking at you, the way someone else is not able to enter into the same room, the way you have your Facebook passwords, RSA and the Diophantine equations are the two most important stuff which there is. More about that in my Instagram, you can go ahead, but I'm not going to stress a lot on it because I talk a lot about stuff like general mathematical curiosity. I'm looking at something and I'm like, okay, what does this mean? Yeah.
Right. So before we hop quickly to the impromptu questions, I want to tell our attendees about something which My Study Buddy is doing. So My Study Buddy has launched a crash course for all the 10th grade students, and we called Bhanu. We invited Bhanu as an extension to help you guys there. Now, talking about the crash course is starting from 3rd of January. Our batches are already going full. 3 batches are already full. We are, enrolling in the 4th batch. So the details for the same are being sent to you in the chat window. One of my team members will be sharing the details for the same in the chat window, and you can check it out. Yes, it is in the chat window. You can get on this number. You can also go to this particular page and check it out. It is going to be extremely helpful for you. Our job, like the way Bhanu mentioned, the job is to practice, 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 and how from 80% marks you're going to reach to 95% marks, and you are going to ace the game of making Romali rotis. That's exactly what we're trying to do with all you guys. So really looking forward to seeing your responses over there. The links for the same are in the chat window. Right. So Bhanu, moving back to some impromptu questions. Ready for it, Bhanu?
Oh, go ahead. Let's
right.
quickly do it.
So 18642 multiplied by 98165.
Okay. 18642 multiplied by 98165, right? So I'm going to tell you the answer from the left corner, which is the beginning to the end. The answer is going to be 1, 8, 2, 9, 9, 9, 1, 930.
Wow, brilliant. Wow. Okay. 6915 multiplied by 483210.
Okay. 6915 multiplied by 483210.
Right.
69. That would be 334 1397 150. Yeah.
Wow, amazing. 919 multiplied by, this one is going to be an easy one. 919 multiplied by 623.
Okay. Let's see how do I do this, right? 919 multiplied by 623. Let's see.
Okay.
The
Right.
answer I'm going to write down 919 multiplied by 623. The answer is going to be 572537. That will be easy. But I'm going to tell you how. 9 multiplied by 623 for me is 5585607. Right? 5607 with a double zero. 5585607. The next thing is going to be 6236230. That's the next one. And then again 5607. 5607. The moment I add these, I get to my answer, which is 572537. And this is just that it's quick, that it looks that it's not something, but I'm doing the same very thing. Nothing very
Right.
different.
Can we do another one like this and we can show it to our viewers?
Sure, absolutely.
123 multiplied by 482. 123 multiplied by 482.
Okay. So how do I do it? I take 400 multiplied by this, which is going to be 49200. 80 multiplied by this, which is going to be 9840. And then 2 multiplied by this is going to be 246. I add them all up, I get 59286. I really didn't add them up. I did it before. So yeah, 598,286. Yeah, that should be the answer.
Right. So you used two different approaches. In the previous question, you took number by number, and here you multiplied one number with the whole chunk because they were the simpler numbers. We can say that.
Absolutely. Yeah. So it depends on you, right? For instance, if the question was 98 multiplied by 99, right? I would just say 9,800 minus 98, 9702. I would not even care multiplying this because I know what do I go for. So it's about this, right? At the end of the day, what makes it quicker? And I think that should be it.
Amazing. Thank you so much, Bhanu, for joining us. I hope our attendees would have gotten great value from you. A lot of people are asking about the crash course. So privately, they're asking me. So I'll just take their doubts up. But thank you so much, Bhanu, for joining in. I would just take another minute of yours and ask our viewers if they have anything to share about this particular session with you. Anybody who wants to share anything about the session or maybe thank Bhanu for the session? Post which I'll be. Yes.
Good initiative by my study buddy doing a lot of stuff. My thing would be that, see, while I'm interested a lot in the board exams, my interest lies in loving math a little more. So for the people who are interested into looking into it, the game link which I've sent you, you can go through it. But more importantly, maybe one of our team members will also reach out to you on telling about how do you start loving math, because that's something which we are genuinely interested to get everyone excited about, because they can never be done through exams by itself, right? So for the people who are interested in, they can probably visit this link which I've sent you right there. Maybe you can just look into it. I think you'll be getting an email from our side on subscribing for a letter which gives you insights on math in a fun way, right? So that should be something which we are really interested in. Yeah.
Right. Thank you so much, Bhanu. I have shared the link for the crash course again. I'll be here. I'll be here right here in this meeting to answer your doubts. And if you wish to ask anything to Bhanu, he'll also be here for another minute.
And for anyone who probably did not get a chance to sort of talk to me or anything of that sort, you can always go follow my Instagram or my YouTube. I keep doing lives where I have a much more interactive environment. So if you would want to do that, you can totally go for it. Neelakanta Bhanu on YouTube, and the fastest human calculator on Instagram. I put it there because a lot of people have been private messaging me. So yeah, cool. You can look into this and the YouTube channel. So either of the places you can find me or bug me at, or exploring infinities, or any of that sorts. And yeah, I think that should be it. See you. Thanks a lot, Nandini, for the invite, and looking forward towards let's say how you guys go about this. See you.
Thank you, Manu. Thank you so much. Right. So all those people are asking me about the crash course. I'll quickly give a introduction about myself. So guys, I'm Nandini Chopra. I am the CEO and the founder of My Study Buddy. So this company, this organization is run by me. Talking about what are we doing with the crash course, what are we doing at My Study Buddy. So here we are particularly focusing on 10th grade students. The education has become offline now. You have to give the exams offline, and you've all studied online throughout the years. So end of the day, every student, every parent is in this situation कि यार करे तो क्या करे, पढ़े तो कैसे पढ़े. And 80% हमने जो पढ़ा है, 80% हम उस पर स्कोर कर सकते हैं ऑनलाइन. बट हाउ टू रीच 80% से वो 95% की जर्नी हमें कैसे रीच करनी है, दैट इज समथिंग वी आर देयर फॉर, एंड दैट इज समथिंग वी आर पर्टिकुलरली गोइंग टू हेल्प यू फॉर. सो क्रैश कोर्स की डिटेल्स यहाँ पे है. लॉट ऑफ पीपल आर आस्किंग मी डेट्स ऑफ द क्रैश कोर्स, बैच साइज, which subjects are we covering and all of that. So I'll quickly answer all these questions एक एक करके. So we are covering 4 major subjects: maths, science, English and social science. We are doing this course totally live. The batch size is going to be 20 to 25 maximum, not going beyond that. All the classes will be live. The classes will be 6 days in a week. 6 days in a week we'll have classes. Test papers will be for after every class, and we'll have 3-hour test papers also. This whole course will be covered in 6 weeks, and we will be doing 4 to 5 revision जब तक board exams नहीं आते हैं. So this is what we are planning to do with all of you. Talking about the dates of the crash course. So the crash course is starting on 3rd of January. Then somebody asked me about the price of the crash course. Does the crash course have a fee? Yes, Khushi asked me about the price of the crash course and all. So talking about the price of the crash course, the price will be 15,000 rupees. It's going to be 15,000 plus GST. That is for 4 months and 4 subjects. So all 4 subjects, math, science, English and social science, we will be covering all 4 of these subjects in 15,000 rupees plus GST for 4 months. So this is the cheapest you can get in this whole industry. If you want one subject, you can also opt for one subject, 2 subjects, or any combination of this, and the price for the same will be told to you accordingly. To inquire more, you can fill a form on this particular link. There is a form. If you open this link, you can fill a form there, and my team will get in touch with you, or you can call or WhatsApp on this particular number. I see somebody raising hand. You can also ask your doubts about the same, that how are we going to prepare for the bid tomorrow. As you already know, the date sheet is coming out, and a lot of you might be very freaked out that what do we really do, date sheet is coming out, how do we prepare. I see a lot of my students saying this to their parents, that kal se to hum pakka phone chhodne wale hain. So I want to know from all you guys, how prepared are you for exams? Because my aim with all you guys is going to be scoring 95 plus marks in board exams. So all years to know what are your plans, what are your aims. Somebody is asking me the price. I've already mentioned. Somebody raised a hand. So can I answer? Anyone? Anyone? Any doubts? This message will also reach to you over mail. So if you wish, you can check it over there as well. This message can reach to you over mail as well. Anyone? Any doubts? Anyone wants to ask anything? Who are the teachers? Who's going to teach? What all subjects and how much time will we cover and all of that? Somebody has asked me with GST, what is the fee? It's going to be 1770, and per subject, if you ask me, it's going to be 4,640 rupees. We're going to cover 4 subjects. Classes will be 6 days in a week, and Sunday will be 3-hour tests. Our commitment with you is going to be for a total of 4 months, and in 15,000 for all 4 subjects. And our aim with you is to score 95+% marks. Right, I'll be here for another 2 to 3 minutes. If anybody wants to ask any doubts, I'll be more than happy to cater to those. I see 51 participants here, guys. I would love to know from you guys. How's your preparation going? What all are you doing? How prepared are you for the boards? Okay, I'm receiving some replies privately that people are preparing, their syllabus is almost complete. Okay, preparing. Okay. Talking about teachers, so I am particularly going to take charge of social sciences. Uh, I'll give you a little bit background of myself. I am from, okay, how many of you have heard of this college called Lady Shri Ram College for Women? How many of you know about this particular college? Okay, I see 5 people telling me I have heard, I have heard. I do, okay. Anyone else? So this is the same college जिसका इस साल cut off 100% गया था. It's exactly the same college. So I'm from that college. It's the best humanities college in the country. So basically, it's the best humanities college in the country, and I'm from that college. I'll be taking care of social sciences particularly. For sciences, we have teachers from IIT. For English, we have teachers who are from Saint Stephen's College. Saint Stephen College, पता है आप सबको? वो ही कॉलेज जो हाफ गर्लफ्रेंड मूवी में दिखाया गया था. One of the best institutions in the country. So, and again, same is the case with the math teacher. Math teachers also from Saint Stephen College. In fact, Bhanu Prakash was from Saint Stephen's College. So, the fastest human calculator, Bhanu, he was also from the same college. So, all our teachers are from there. In fact, the math teacher is a very good friend of Bhanu as well. They are from the same batch. So, yes. Bhanu was in a school in Telangana. I forgot the name of the school, but he's a resident of Telangana, and he's also working with the government of Telangana. Right. Anybody else who has any doubts, who wants to ask anything? Okay. Okay, guys, I'll be here for another minute or so, and post which we'll be ending the meeting. Some people are asking me for some tips in exam. A lot of you are saying that I like the session, good session, I loved the session. So thank you so much on that. I would love to know quick feedback on the same. How many of you did like the crash course particularly? You got to know many new tricks. Okay. Okay. You can write to me privately as well. So my name is Nandini. You can write to me privately as well. How many of you did like the session? How many of you found it useful?